Hey, Steve with Trimble, and this connected construction tip is for our construction management and design build firms and how you can use the X9 laser scanner behind me, along with FieldLink that you see on my screen right now, uh, that usually runs on a tablet, to do concrete edge analysis, camber analysis, really anything that's designed and anything that's modeled, and you scan it, you can run an analysis too. So column locations, shaft locations, sleeves if they're there, um, really just about everything. So here you can see we have a couple scans, actually a couple more if we move out of the export screen. Um, and a model of an existing building. So FieldLink will bring in Revit, Navisworks, IFC. IFCs are usually better, but it's just anecdotal research, or I guess knowledge. Um, if I tie these scans with a resection to the model, I'm going to be more accurate, but I actually just manually align these. I can have different sets, but obviously, and not obviously, if they're not registered together, they may have a little bit of a deviation between the two. So I try and resection to control, and then I know that these set of scans and these set of scans would all align on top. But here I can quickly check at the column from the first floor, and where I can see some of my, like from second floor to first floor, I can usually see if they're going to align. So I can come in here and actually see that here with the top scan here, kind of showing me down here where they're aligning and mapping correctly on top of each other. Maybe not that one. And what I'm looking at here is actually to make sure that the round scan comes in on the bottom there, which it does over here. Obviously, this one registers the scan down below. But what can I check? So I can check the first floor. I will use a couple different views. When I bring in that model, I usually just go blue view, and then I can jump in and out of using solid model or not. But I can come in here and just clip out the ceiling or the roof of the floor of the second floor, and run an inspection. So here I have that. Actually, this is the second floor column inspection that I can run here by just essentially having the view I want with the layers I want turned on, and then just hit the button for the inspection cloud will actually show me this. If I use the outline view, sometimes that pops up a little bit better, but I can run that inspection, see that these outside columns all line up fairly well. I'm looking at these color maps to see that. If I need to bring this in, I can bring it in tighter to whatever tolerance I want. So here it's kind of showing me those columns are lining up well. Other things I can run an inspection to, I can do it to the floor, also tells me. We'll get to that here in a second, or just even the camber. So in this camber, I can see down here, the floor is bowing pretty low, almost 1.5 inches, but at the extent, it kind of lines up perfectly. So I can export this inspection. I can do a PDF report, which is pretty nice. It'll, for one element, shows me pretty well what's happening, but obviously I can't zoom in here. So the other thing I can do is just export that point cloud as an E57, LAS, or LAZ. If I do that when I want to go back to Autodesk, I would just bring that into recap before I make a recap file, and then I can bring it into Revit, Navisworks, and AutoCAD. That's the camber inspection. In column inspection, I can also look at the floor analysis. I have a couple of those already done. So here, and let me turn off the model so we're not looking at it. I can just go in, turn off that model. I have my floor selected. If I switch to a elevation view, I can actually see my reference elevation is whatever I defined it to. You can actually see where it starts to lower down quite a bit. I can run the same report, and looks like I still have my grid line turned on. I can essentially create these points, which I have already done. It'll be a grid line spacing of 5 foot to this reference elevation. Anything that's higher is going to be red. Anything that's lower than a quarter inch is going to be blue. But those points can be exported as a DWG or CSV, and they'll be in the project coordinate system because the scan data is tied to the model there. I can run that same kind of camber analysis just using the floor tool here, which you can see this is showing me low, whereas these points are all within tolerance. Although I may need to do a smaller grid to make sure I get that on the beams itself. So column check. Other thing we can do if we move outside of that is edge of concrete analysis too. So I will do that with, I can do this on the first edge. I can run an inspection for this. Turn the model back on. I can also take some points. So I'm actually, because this, you can see here, this is not really modeled there. I'm going to go up to the top or the second floor to do this one. And then I'll bring this guy over. And to make my life a little bit cleaner, I'm going to turn off those points. So there's my edge of concrete or edge of steel. Let me bring this up a little bit higher. So here I can check that. I'm going to actually bring this in even more so I'm not looking at the rest of this overhang that hasn't been built yet. But there is my edge of concrete. I can run that inspection too. You can see it's a little far off. If I want to denote that the inspection will send over, I can also come in here and I should be able to actually click on this to say this is my edge of concrete. Let me double check that to make sure I clicked on the top side of it, which I did. What that's showing me is that'll create a point that I can then export to show essentially how far off that is, or I can come back and run the inspection again, just to show you the distance from the scan data. Now, because I don't have just the edge of concrete turned on, it may actually show me a measurement that it's good because it's on top of the floor. But I'll double check to see where that model actually ends. LineWorks sometimes a little difficult to see through. So there's that. Let's turn this guy on here. And the other thing we'll do to make this a little bit easier to tell is I'll bring this guy in and this guy over. And to get rid of the floor below it, we'll just chop that off. So there is my distance from model. You can actually see where it does end up short from that scan point to where it should be. So I can export that out. Over here, we're seeing it lines up closer to the edge of concrete, so that is nice. So there's that check. The other thing I can check is my shaft analysis or riser locations. With this, I'm going to generally, I can turn this on. I'm actually going to need to turn those other scans back on to see it. They're there. So here I can actually see for this kind of riser location where they had some design beams that were offset. Again, I can export the inspection cloud, or I can send the full data analysis because the inspection is just to the preview cloud that's made for the tablet. If I want to send the full data analysis, I can export the RCP, and that'll bring in the full resolution when I bring it over to Revit or Navisworks. So there we can see that offset. I could do that inspection report again or create a point that'll show that, but generally the point cloud is going to show me more detail than just about anything. Now, one tool I suggest for larger design build forms, construction management, this is a couple story building, so a lot of scans. If you can export a TDX, you can bring that into RealWorks, and RealWorks is going to allow you to do just more analysis. So vertical wall analysis, wall planes rather than just points and scan data. You can bring that over. So I exported that RCP. For RealWorks, I'd send a TDX. That'll send all these scan data. And then inside of RealWorks, and we'll link to some other videos, I'd import that scan data. It'd already be registered and georeferenced, but I can check that here. And with that TRB, so FieldLink, you can bring in really any type of model. It'll create a TRB, which is a trim BIM file format that can be imported to Revit or into RealWorks. You can bring in a IFC as well too, but if you have a Navisworks or Revit, sometimes it's easier to just make that TRB or trim BIM file for 2025 in RealWorks and drop that in. So here you can see I have actually brought in all this stuff. Before I get there, I'll show you how to edit this. A lot of times what I will do is create a mesh, because that just makes it easier for me to run a scan to model inspection like we were doing in FieldLink. But with just the elements I care about. Obviously, the full IFC is going to bring in the full IFC drawing, which is going to be pretty large. And I don't really care about those other elements. So if I create them to a mesh, I can then segment down or clip up on a point cloud to that region that I care about and run that inspection. So I just converted what I saw to a mesh. I then usually combine them all to one mesh, because then it's a little bit easier to deal with, because then I don't have to click a bunch of stuff. And so I'll put that one right there, turn this guy off. Oh, I don't want to move mesh. I don't want to move the mesh. I wanted to merge the mesh. So moving it will move the coordinate system. I generally don't want to do that after I've aligned it. Just going to create some headaches on the back end, but that's an easier way if I just want to do the analysis and keep that data in RealWorks. But here, so the full mesh I brought in actually looks like, again, this. I don't really care about that stuff, so I'm going to run an inspection. And this is a great way to really quickly see the in and out of this project, where things were built differently than where they were designed. So I can, again, with this inspection cloud, it'll colorize it like in FieldLink, but to the full resolution, or just to what I segment it down to keep that a little bit cleaner. Good for column analysis, vertical analysis. And then also in here, we can do like floor inspections and wall inspections, wall verticality inspections. This is great if I'm just comparing it to the model. So once that's done, we'll show you that. In the meantime, that data will either from FieldLink, if I bring it into recap first, can come over here, or I can just export the inspection as an E57. Again, bring that into recap and then into Revit or Navisworks for that, how that looks. And after that inspection is done, we'll get back to it. I can bring in, let me save that project. I can bring in the shaft or the cutout analysis that we saw. That would be under here. Documents, FieldLink. So this is actually if you're just going from the tablet. Floor inspection. Let's see where that one pops up at. That is a floor inspection. So let's manage links. Change this to point clouds. Unload. And I'm going to try and get that inspection that we just did. Oh, maybe that was it. We'll come back here, reload. I need to re-export this one out. Let's see what we named it as. We'll call this riser, and then reattach that one. So I can bring that point cloud in. Back to RealWorks, and hopefully that's about done doing the inspection. We can look at what the inspection looks like there. I again can export that out as an E57. I will need to bring that into recap before I can see those the color map that we saw there. I can in RealWorks do some basic modeling or convert this point cloud to a mesh if I want to do the kind of model to model inspection that Navisworks does. I would generally recommend against that just because you're kind of downsampling the point cloud. It does make it smaller, but if you can share the point cloud, it's just, to me, it makes more sense. But obviously, do what works for you. Let's see where this one's at. So that one did export. And I should see riser. Yep. And so if I go to the foundation level 2, we'll see level 1 maybe. Graphics, point clouds. Try level 2. Visibility, graphics. Maybe I can't see it because 7. Let's go back here. Oop. There's my riser locations. So I can share that as well too. So level 3 maybe? Not really sure. Let's see. Why is that one popping up? Well, that should be level 2. Probably a view setting. Let's see what we have here. Oh, that makes more sense. And there we go. So it's just the wrong view setting. So here we can see kind of those riser locations. Back to RealWorks. We should be hopefully about done creating that export. Just about. Once that inspection cloud is created, I again can export that as an E57, bring that into recap. Or what I'll link to on the bottom here is some floor analysis and map or wall analysis that we can do, as well as some like stringer analysis that you can do from modeling. So here is that inspection completed. You can see where we start to move away from the outside here, where it's getting up close to an inch off from the model. And I can create this as an inspection cloud and share that. If I want to do some additional, not just the inspection cloud, but some additional analysis, I can use the wall verticality tool, which we'll link to in the video, as well as I can actually convert scan data to mesh data, like we discussed earlier, or actually just start to make drawing lines out of the scan data. So thanks, and look below for some of the related videos on this if you're a construction manager or design build firm. Really, once you have the model and scan data, you can compare anything that anyone built for you and see if they put it in the right spot. But we'll link those videos below, and please reach out to your nearest building point representative if you have any questions. Thanks.